I'd like to interact. I'd like to interact with a few of you. Just get to unmute. Tell us where you're joining us from. Tell us you could tell us your experience with design, what kind of software you use, which code you refer to, or which code you reference, and probably your favorite book that you use for your design. So please feel free to unmute and engage with us. Also, drop the flag of your country in the chat box so that we can know who we have here. All right. Also, if I'm audible, please drop the flag of your country. Let me know that I'm audible and that you can all clearly hear me.
Hello there.
Hello, Emilio.
Good evening to everyone. I am
Evening.
Emilio Odongo Jr. from Uganda, and mostly I am entirely new to this, but I am a fresh graduate of civil engineering from Uganda Technical College, Lira, and I have been exploring the world of design, and mostly I've been using ArchiCAD. ArchiCAD 26 is what I'm currently using, and I haven't really explored the structural bit, but that is what I look forward to getting into next. So I'm really glad to having joined this and been a part of this from the very start, and I hope to learn each and every detail and pick each and every lesson from this engagement going forward. Thank you very much.
Super, super. Thank you, Emilio. You are really, really eloquent, and we understand where you're coming from as a recent graduate. And that's the reason we have this webinar to expose you and everyone else who has not been exposed to structural design, and anyone else who would like to have a taste of of another software, probably use another software, and you'd like to get a feel of how a robot functions. So that's why we have this webinar, right? So thank you, Emilio. I'd like to hear from three more people, and then I will let Engineer Abraham take over. So who are going to be the next lucky three people? So I've heard from a Ugandan. I can see we have Kenyans, we have Nigerians, we have Zimbabweans in the meeting. So someone please feel free. Asu, Asu,
Uh, Hello, Gatimu, can you hear me?
yes, I can hear you.
Oh, okay. Thank you very much for this webinar. I'm currently a recent graduate from Federal University of Agriculture, Abeokuta in Nigeria, and I design structures with Protal, which is for the analysis and the design. I use Protal structure. Or I noticed there is more collaboration and synchronization for robots and Revit, and it's one of the software I would like to learn, like robots, so that I can have more collaborative workflow when I'm using Revit after my design. So I'm looking forward to learn from the training as well.
Super, super. Thank you so much, Asu. Thank you for sharing, and I agree with you. There's a lot of interoperability with robot and Revit, and it works really, really well. So it would be a nice tool to have in your arsenal. So, thank you, Asu. I'll hear from two more people, and then I'll give the meeting to Engineer Abraham. So, two more people. I've heard from a Nigerian, I've heard from a Ugandan, so I'd like to hear from another nationality. Anyone else who has not had their countrymates represent them, please feel free to unmute and just say hi. You don't have to say a lot. Just say hi and then we'll go to the next person. Someone.
Hello, am I audible?
Hello, Marceline, you're audible.
Yes, hello. I'm so happy to be here today, and I'm from Kenya. My name is Marceline, What I expect to gain from today's session is to delve deeper into structural analysis. My experience so far is theory, because I'm currently in my fourth year in university. So the codes we usually use are mostly the BS codes and Eurocode to some extent, but not as much. So I'm hopefully going to learn how to use them more effectively in this session. Thank you.
Super. Thank you, Marceline. Marceline is part of our ongoing training, and it's nice to have you here. And all the others who are part of the training, it's also nice to have all of you here. So thank you once again, Marceline. I'll open the meeting to one more person as Engineer Abraham prepares to take over. So one more person who will be the lucky person to close the interactive session for us. One more person.
Yes, hello.
Hello.
Yes, I'm Edwin Juko from Uganda, and I'm glad to be here. This is my second training session, should I call it, with Broads Hub, and it's always a pleasure to be a part of them.
Okay, super. Thank you, Adrian. I am also aware that you're part of us, and it's always nice to have you here with us. So, thank you once again. Thank you, everyone, for joining us tonight. We really don't take this for granted, and we always feel honored when we call out for you to join us on webinars and you show up. So, thank you. And with that, I will welcome Engineer Abraham to take over. So, Engineer Abraham, are you in a position to take over?
Hello, Engineer
Hello.
Gatimo. Good evening.
Yes.
Am I audible?
Yes, you are audible on my end. If you think Engineer Abraham is audible, please type a 1. Let's know that he's audible on your end as well. Let's know that you are with us. Type a 1 if he is audible on your end. Super. It seems you are audible everywhere, Engineer. So let's go.
All right. Thank you so much, Engineer Gatimo. Abraham Nyanja. If you've been in the Roads Hub community, the name is not, it's familiar. I'm part of Roads Hub team. It's a pleasure to always have you. Yeah, this is the community where we get to learn and grow together as a team, as fellow engineers across the world. And yes, it's still a pleasure to be in such a world where technology is advancing. We are able to meet with different and fellow engineers from all over the world, and we share. Yeah, it's a pleasure to have you. So this is to introduce you to robot structural analysis. So it's not necessarily that we are going to dive so deep, because if we dive so deep, we don't need 2 hours to fully exhaust a robot. It's a very good software. It's an advanced software that handles different structures from buildings to bridges. I understand, I've seen some comments of people who are already into structures. Yeah, there are some structures you're unable to design probably using one software only. You might have to interlink a few softwares depending on their capabilities. For example, I've seen, yes, Engineer Olive, I'm not sharing my screen. I'll share my screen, or worry not. I was just giving a simple background. If you've been in structures and those in structures, as the structures become complex, you realize you might need to interlink softwares that are advanced or have a better capability compared to others. For example, when it comes to bridges that are composite, I've seen engineers combine different softwares like Robot and Midas. Robot does the concrete part, then they use Midas does the concrete part, then they use Robot to do the steel analysis and design in case of composite bridges. You realize, allow me share my screen. So you realize Robot has very good advanced steel design and connection tools. So many people end up because it has very good connection analysis and design. I hope my screen is visible. You can just type a one.
We request you zoom in, please. Just zoom your page, maximize
Yeah,
it.
it's okay. It's okay. I just wanted to confirm whether you can see my screen.
Yeah, we can't see it.
All right. So allow me open worry not about whatever you're seeing. So this is the robot structure analysis software. I have 2026. You might be having other versions. Yeah, it's all right. So now, as we've said, it has very good advanced design and analysis tools. For example, we are going to, if you're to go into buildings, you would use this purely for buildings, then flames and others. But in most cases, if you find very complex structures that are composite in nature, probably they have the steel part and they have the concrete part, you might find designers interlinking different softwares. And that is where the power comes in Robot. There are softwares I know that only do buildings, and you can't use it to, for example, analyze moving roads, analyze bridges, but Robot has all those capabilities. So I guess I've given quite something good. So this is how it will open. This is how the interface will look like. It might not look like mine if you've not worked on some other structures. So it will open with other templates that come embedded within Robot. So to open a new project, you would just click on new, but as a Robot, depending on the structure you're going to model, is it a building? Is it a frame? You might want to do a shell. It has a different, so to open a new project, you can open an existing if you have any you've worked on, or you can just open a new project. So whatever you've worked on will appear here. So for the first time, you just open new. So, and this is where it becomes interesting. The first four components I used to model all the different structures you might need: building, load takedown, frame, shell. Now, these others are more tied to, for example, an element you might need to just analyze a slab just to confirm. You might just need to analyze a frame. You might need to analyze a connection. So these ones are element dependent, depending on what you want to quickly analyze. So at the moment you select what you want, I don't know if someone is trying to communicate to us. All right, so this is the interface. This is how it will open on your end. This is how it looks like. It's not, I don't know if someone is trying to communicate to us, but I will proceed. This is the interface. It's organized in such a way that you will model, you will apply the loads. This is where everything is modeled from. You apply the loads, you analyze, you see your results, then design, and the different other tools. So it is organized in such a way that you will model, you apply the loads, you will analyze, see your results, and then design in simple terms. But all these come with a different, I think most of the softwares, you find these are almost the same. For example, file will always control the entire project. So this is where you can still open a new, open an existing, you can save or import. If you have a CAD file, a DXF or a DWG, you can import it and save it in the background. Yes, still those that have been in structures, the DXF should be a format that is common. You can model in AutoCAD, save it as a DXF, then you can import it to various softwares. Procon recognizes this and others. So yeah, you can import a DXF and a DWG. These others are normal commands to print, but cross a project, what it does, it crosses what you have currently, not the software. It's exit that crosses the entire software. So if you have a project you want to open, you might close this and then open another one.
Excuse me. Hello.
Yes, engineer.
I just wanted you to clarify before you go any further. On the opening page where you have to take down, you have slab. Now, are those like templates? Because I'm trying to relate it with Revit, whereby you have a structural template, you have a construction template, you have a mixed. So I need to know whether if I open the takedown, I will miss some components. If at all I open another component, I just want to be sure to know that. Well, for
All right,
example, when you open the architectural component in Revit, you realize some issues are not activated. Is it the same with the robot?
all right, I will take that question since it's at the beginning. Probably those other questions, we shall have them in the chat box, then I will answer them. I also have other colleagues on the platform. Engineer Gatimo will be answering some other questions. So as we said, for example, when you open new, depending on whether you're going to model a building, this one will come with components that will help you analyze and model a building very well. The moment, for example, you want to do a concrete structure that will need you to have a moving road analyzed, this one will not work. But there are other components like the shell that will come with commands that can capture moving loads. So you have to specify exactly what you want at the start. For example, when you open the building and you come to the loads and you go to the special loads, you will not see anything like moving loads. But when you use the shell and you come to the loads, you will find the moving loads format within the special loads. So you have to specify what you want right from the start. Otherwise, for example, when you open a building and you want to model something that captures moving loads, you will never have moving loads within that. So you have to specify what you're going to design right from the start so that you have commands and settings that will match what you want.
Thank you
So
so much.
we shall have other engagements in future. We have programs that will be set. We shall cover concrete, steel, and move into various advanced components. So we shall be moving from one to the other. So this is specifically if you're to work with a building. So the file edit is where you do the normal editing. You can copy, you can move things, you can divide, you can intersect, you can trim. So this is basically an editing. Whatever you want to edit, this is where the editing is done from. Whatever you want to model to edit in your model, it will be done from here. So from the view, this is where you get to, you can zoom, you can pan, but what is most interesting here, for example, if I come to grids, I hope you can see the small dots. Yeah, so you might not want to see the small dots. So this is where you get to turn them from. You can turn them off. So you have a clear model space. The same applies to the ruler. You can turn it off from here. So this is where you get to change a few things within your model. But as I said, the geometry, this is where all the modeling is done from. And because, for example, you can't place a column, then again come back to the geometry so that you pick another entity. That is why all the entities within the geometry are all right here. So you can see these are the grids, these are the beams, columns, floors, walls, openings, all of them. Most of them are right here. So instead of going back to the geometry to pick something, all you do is pick whatever you want right from here. So yeah, although the geometry, that is where we model from, all of them are available here to our exposure for faster modeling. So these others, I'm not going to go to them because you can see they are not activated because we have nothing in the model space, but we are going to see one by one. And as we model, they will get activated. In the tools, I'll jump these four because we are going to see them, worry not. In the tools, this is where you find the dimension lines you might want to dimension. And most importantly, this is where we get to change a lot of things. For example, if I go down to the preference, you can see you can change the language, change it to Chinese so that you probably, but it depends. Your language might not be here, but yeah, this is where you get to change the language. These are the general parameters, and you get to organize the toolbar. What is most importantly in the tools is the job preference. Now, in the job preference, as we said, a robot is a very advanced software. It has over 70 plus design codes that are captured. Now, within the job preference, this is where you get to change the dimensions. You can change the dimension. You can see as per the building, I think the last settings I used, my structures is in the structure dimensions will be in meters. The others are in millimeters, reinforcement in square millimeters, then the force kilonewtons, meganewtons. And now the database, for example, for steel, it is set to use the UK sections. There are vehicle loads, as we said. There are other standard loads, building bolts. And now when you come to the design codes, you can see steel, aluminum. If this is not the code you want to use, you don't want to use maybe BS or Eurocode, you can choose any other, for example, timber. When you come there, so you can choose something else to use depending on the design codes you're working with. For example, reinforced concrete structures. You can be able to change depending on the code you want. So you can adjust, and then when you click on more, as we said, there are very many, so you can choose, you can look for the specific code that matches what you want for example, aluminum, for reinforced concrete. There are very many. I'll leave them set as Eurocode and So tools, this is where you get to change the codes. So now there's something I want us to model so that we make this interaction a great experience. So I have something small here. It's a structure. It has columns of 200 by 500. It has beams of 200 by 450. So we are going to just try to replicate this within the shortest time possible to just show you the power behind a robot. So I'll go back to, so now every structure, as you've seen, it has grids. So as we said, when you go to the model, this is where you get to adjust everything. For example, if you're still not sure of what you selected, you have a chance to change it again. Geometry, then the structure type. You can be able to change it again to match what you want. The axis definition, this is where we get to define the different grids. But before we define the grids, because that is going to be our basis, I'm going to first go to stories so that I set the story height. So this is what I last used. You have your building base set at 0, 0. This will be the base of your structure. So you can define stories graphically or manually. So for example, when you choose manually, you can set now the story height depending on the structure you're going to design. Does not mean when you open the software you have the 3 meters. No, it will capture the latest modifications you did. So depending on what you have here, all you have to do is to delete whatever is there, put in your height, your story height, then you just add it and you set it. So what robot does, because even if you have 20 stories, all you have is to set one story, model that, check it. If it is okay, then you can use that story to generate all the other stories you want. So if we set it at 3 meters and you're good, just apply and close. So now what the axis does, for example, when you come to the Z, this would be the story height. You can see it is in gray color because it is already set within your stories. So now all we have to set is the X and Y. But before we do that, you can see there are very many axes that you can use. I think most of us are familiar with a Cartesian. There is a cylindrical where you get to specify the angle, the radius, then arbitrary where you can just pick points. So using the Cartesian, we have the X and Y. Now, depending on our structure, this is where we get to define the X and Y. So literally what we are going to define are the different grids, where the different grids are representing where we have main elements. So I'm going to be minimizing because I didn't open this meeting using the Zoom link. So I find myself, I can't navigate easily. So this is what we are going to do. This is the structure we have. I'm going to set the 0, 0 X and Y at this location. So meaning if I set the 0, 0 as this point in robot, all these ones in the X will be positive, and whatever is in the X this side will be negative. For example, I have this 580 will be negative if I set my 0.00 as here. So all these grids will be in the positive, this one will be in the negative. The same applies to the Y. Because I've set my 00 here, so all these, the 430, the 3090 will be positive, and the 870 millimeters will be in the negative Y. So this is what we have. I'm going to try to duplicate it. We have a 4.02, a 3.4, a 2.36, 3.4, then the 580. The same applies to, I'll have a negative 870, 430, positive, the 390, 3090, like that. So these are the grids I'm going to set in robot, because you set them at once and then you're done. All you do is to place the elements. Okay. So this is the robot. So we have X. So we are going to add a 00 so that it marks our 00 coordinate, and they're going to be numbered from 1. You can change to different numbering that you want. So we shall number the X from 1, and we shall number the Y using AB. So X, we've set the 00. So what I'm going to do, let me just toggle this so that so I'm going to have a positive 4.02 from my 00. I'm going to add a 3.4. I'm going to have a 2.36. Then a 3.4 will repeat. So it is symmetrical along this axis. So what is here resembles what is here. The same applies here. I have a 3090. Okay, here it changes. All right. So I have a 3.09, a 1.42, 1.42, 2.19, 0.98. This is okay, 875.8. All right. Okay. So X00, I'm going to have the first, which is a 4.2, 4.02. So all you do is type in the next distance where your grid is, which is 4.02, and you add. But now to add the next grid, because it is in increment, you don't need to, all you do is double click here, the calculator will pop up. So now we've stopped on 4.02. I will add the next grid, which is at 3.4. So all I do, I'll say equals, then press OK. Whatever total will pop up here, and then I will add it. I'll get the next grid. The same applies to the next, that is at 2.36. All I will do, I'll get the 7.42. I'll add the next grid, which is 2.364. Equals, I'll get the total, I'll press OK. It will automatically populate here, then I'll add the grid. So we've passed the symmetrical point. I'm going to add the 3.4 and 4.02. So from where we've ended the 9.78, I understand there are people that can add with their heads, but so you just press OK and it will populate here, then you will add it. So I'll add the 4.02 from the 13.18. I'll add the 4.02, just like that, equals OK, then it will populate here and I'll add my grid. So I'm going to add the last one, which is 0.58 from where we've ended the 17.20. I'll add the 0.58, get the total, okay, it will populate here, then I add it. You're done with the X. Someone is writing on the screen, so worry not. The same applies to Y. We set the 0, 0, we add it. It is going to display as ABC onwards. So I think in the X, we forgot the negative 0.5. Worry not, you just need to type 0.5, give it a negative, and add it. It will be added. So we shall go to the Y. We have a 0, 0, but it has a grid that will be in the negative 0.87. I'll add it. Then I'll add the first positive, that was a 0.43. So I'll add the 0.43. I'm literally creating grids. You're going to see at the end. So I'm going to, from the 0.43, I'm going to add now the 3.09. So I'll say 3.09 plus where you've ended the 4.3, the 0.43 equals, it's a 3 point, then okay, it will populate here, then I'll add it. So I've gotten the next grid. I'm going to add the one of 1.42 to the total, which is 3.52 equals, okay, it will populate here, then I'll add it. This is repeated, so I will have the 1.42 again. I don't know why someone is enjoying the screens, but it's all right. So I'll add the 4.94 equals, then okay, then I'll add it. I'm going to add the last two, which is 2.19. 2.19, I'll add the last grid. Toby, I think, Engineer Toby, 2.19. So I'll add the last grid, which is 6.36 equals, then okay. I'll add the last one, which is 0.98, add it to the last grid, which is 6.36 equals, okay, add. I think there is a grid I didn't add, but it's okay. So when you're done, just apply and close. So this is basically what we've been doing. And you can see there are two views that are open. So I will be explaining more on this as we work. So there's one that is called view that has the 3D part. So when you come down, you can see we have the stories we set as 0 and 3 meters. But now within the 3D, you can be able to access different, you can access the XY in 3D, the Z, you can access various planes. Now this plan is more of the XY. So if I go back to the view, I can work with XY. It's still the plan, though with this I can easily navigate between views. or you can use this tube to navigate within different views. So using this tube, you can rotate and do all the magic you want. You can use the tube or you can use the XY and the 3D. So now these are the grids we created. We have to, as modeling is done, we shall have columns, beams at this floor, then we shall have floor slabs on this. So let us work through that very fast. To model a column, I'll go back to the plan. To model a column, for example, if I want to place a column at the intersection of this grid or this, all you have to do is launch the column. Remember, you can launch it from here, or you can go to the geometry and launch the column. It's still the same. You can launch it from there, or you can just go to the columns here. It's still the same command. Yes, we are in the plan. That is good to note, because depending on the view you're in, it will affect how you model. So I'm going to just go back to the columns. I think we have columns of, I'm going to confirm. So we are going to pick out the column section that we have. I'm going to note it. I'll pick out the beam section that we have. Then we come back right here. So we are going to place columns. This is the grid that is set at 0, 0. So we have a column here. We have a column on this axis, a column here. So we are going to place these columns. We have columns at this axis. We have columns here, and so on. And all the columns are 200 by 500. It does not mean every structure you get, you will have something like this. You probably will have an architecture drawing from an architect with, you might have proposals of the locations where you want certain columns, and still he might propose the different dimensions he wants. He might not want a column to protrude out. He might want a column maybe to protrude at a certain point in order to communicate the different views that you want. So it's not necessarily that you have this. You will probably start from an architecture drawing and then position your columns, and then you have something tentatively to work with depending on the position of the columns you have decided, and then you begin from there. So we are going to begin at this point, but in real world, you won't begin at this exact location. So we are going to place columns here. There is a column here, and here, then at different grids. So still you will forgive me, I didn't open this in a Zoom app, so I'll keep moving back and forth. So we shall have a column at this. Okay, I will. So we shall have a column at this location, and this location, the same applies to these two, then at these grid intersections. So how do you place a column? You launch it from here, but now you have to specify the column you're going to model. Timber, we are going to do a reinforced concrete column. Section, as you are aware, robot is integrated with Revit, so every element has to carry a certain section. So we already have a section of 200 by 500, but I'm going to show you how you create yours, because you will not have that. So all you have to do is you click on this ellipsis button, and this new section will pop up. So we are modeling a reinforced concrete. Material is concrete. You can specify its class from here, or you can specify it later on through the object inspector. We shall see how you can adjust a few things, but we shall take C20 for the start. Still, it depends on the structure you're modeling. All these come from the different specifications. During the training, we shall dive deep into where all these come from. Because, for example, I will apply loads at a certain point. We might not go deeper into where the different loads come from in Eurocode, but that is covered in our training. So as you can see, you can choose different circular, different columns that you need. So we have a B of 200 and 500. And as you're aware, B and H, their ratio govern how the column will be designed, whether it will be designed as a column or as a wall. So I'm going to label it reinforced column 200 by 500 millimeters. You will have projects that have very, I want to add something. So reinforced concrete column so that it does not pop up that it is already. So reinforced column 1, 200 by 500. You have structures that have very many dimensions of columns. So it is better to note your column with that specific dimension. It will be easier to track. You can give it a color, or you can leave it set as auto. Let us not, but you can, let me just give it a random color. You can give it a color. Now, when you're done, just click add, and as you can see, reinforced column 1 has been added here, and then close this. So with this column and in your plan, as I said, where your model is very important, because, for example, when you go into view, it has very many views. So you need to know exactly where you're modeling and the story that you model. For example, we are on story 1 and we are in the plan, all in the XY. Okay, so all I have to do is specify the beginning, and as you can see, the C20, then the height is already set. Remember the story height. Then the orientation is the negative Z. For example, if I place a column here, you can see it has been pressed. So it will be pressed at the grid intersection. And note, I guess you see that rhombus. The rhombus, the circle, and the triangle are critical in robot when you're modeling. You know exactly where you've placed your column, so I'll just place it at that and that. So I'll place this one at this location. So this is how they have been placed. We are going to see how you can orient them further. So now that you only have grid, so you only see the rhombus, but as we model, you're going to see other entities coming. Elvis, Tibeti, Please don't write on the screen. So I will close this. I'll go back to the view and we'll go back to the 3D. So this is generally what we are doing. So down here, you can see we have the node numbers. For example, if I turn on the nodes, you'll see the different nodes. And why they are nodes, we shall see why. You can see the different node numbers. I will toggle these off. Now, to see the section properties, all you have to do is click on the section shapes. And this is what we are modeling in 3D. So I'll go back to the plan and continue placing the columns. Remember, you don't need to go back to the geometry. You can just pick the command from here. So I'll just confirm it is still set on reinforced concrete 1, and I'll just pick, I'm going to pick these points. Okay. I don't remember exactly where we had columns, but it's all right. We can change that later. It's okay. All right. We can change these ones later. So I'm just snapping at the moment I move next to the grid lines, the rhombus will show up. Then I'll be able to snap. I'll go back to the 3D just to, so this is what we've done. I've placed columns at different grid intersection. So I'm going to go back to the plan just to confirm what we have. So we have a staircase here. This grid has no columns, yes, but this one has, and this one has. So, okay, we shall change the orientation later, worry not. So I'm going to go back to robot. So we have, I'll place this one here and this one here. So these would be your columns in 3D. Remember the base we set, it automatically captures this support because we set our base as 0, 0. So robot understands that where it finds your base, that is your 0, 0. So it will just automatically attach a support. But of course, as you do analysis and model, whatever footing you model will also operate automatically within your base. So if you analyze the footing and finalize its size, it will automatically come and populate here.
Excuse me.
Yes, engineer.
What happens when the column is slightly away from the center? How would you position it?
Yes,
When the
we are
when the
going to.
column center is not in line with the grid center, I mean.
Yes, we are going to cover that because the drawing I'm using, it covers that. It is not in line. So as you've seen, we've randomly positioned columns, but this column actually is not at the grid intersection, like what engineer is asking. Yeah, we are able, what we have done, because you don't have a grid at this exact intersection of the column, the grid you have here. So you can first position it here, then you can use the edit commands and move it. We are going to move them, worry not. The same applies to these columns. As you can see, they are flashing. So, but we have initially placed them at the grid intersection. So to do that, or before we do that, we can first Because for example, these columns are positioned like this. These ones are, so these ones, I'm going to change the orientation of these 4 columns. The same applies to these 4 columns and these ones. So I'm going to change their orientation, these columns and these ones. As we said, you can do edits on your drawing. So I will close this to change, for example, these columns are not oriented in this position. They are meant to be in this position. The same applies to these ones. So all you have to do, you can, because for example, the story one, we have columns, but those are all the columns. So this is where the edit tools come in. For example, this is where we do the editing from, but still you don't need to go back to the edit. So when you come here, these are the edit tools. When you click on this, you can position them where you want. These are some of the edit tools that you will use so often. So as you can see, this is the copy properties. This is the move stroke copy. So before I do anything, I will confirm that I'm in the plan. So I will select these 4 columns. And now when you come to the object inspector, you'll note that you have columns highlighted that have been selected. And now from here, I can change, for example, when you open, when you go, this is story 1, analyze. When you go to the gamma, you can see it is set at an angle of 0. If I give it 90 and press enter, the columns are oriented in the direction I want. So I can do that for this. So I'll just come to the gamma and give them a 90. Then they will be oriented in the direction I want. So I'll also change these ones. I'll just change their gamma to 90 and reorient them. But still, they are not yet where we want. So I can still select them because we need to push them. The beam is 200. This is 500, so we need them to flash. So I have to pull them backwards by a 50 so that they flash with the beam that I'll place in this position. So to do that, when I still have them selected, this is when you come to these edit tools. So you can be able to move, to copy. So when, for example, I launch, you can see it is currently set in copy. So I don't want to create a copy, but I want to move. Okay. So now that translation vector, the dx, dy, dz, this, for example, when I would just, when now, as you can see, because there is an element here, the circle comes, the circle marks your node. The triangle marks the intersection of your object you've placed, or it can be the middle point of a column or a beam. The rhombus marks your grid. It is very critical when it comes to modeling because when you snap at a node, surprisingly, the node is not at the same position as your grid. They have a small deviation. So when your placing your elements, you have to be critical. At first, you have on the grid, so you have just the rhombus. But as you place more elements, now you can see at this point, there are 3 different positions we can snap to. So this is very important. For example, if I have the rhombus and I snap to this, you can see the translation vector at that specific position is 0, 0. But when I move, for example, in this direction, you can see the dy, not the dy. If I move in that direction, the dy has changed to negative 0.98. Meaning, if I want to push this column, I would just need to put a dy that is equivalent to 0.05, and the columns will reorient. So I'm going to just click on the translation vector. I'll wait for the rhombus 2. Then now, and this is the beauty of Revit, the X, you remember the X grids, the Y, you remember the Y grids, and the Z, we are at story 1. You remember the Z. So at this specific location, it will take your translation vector to be 0, 0. Everything will remain 0, 0. When you move, it will update. So I'm going to just right click and just put a 0, 0, 0.05, then I think it's a negative, 0.00. I'll just come back and give it a negative. Then when I click execute, as you've noticed, the columns now move so that they intersect. Now, when you come back, you realize the translation vector is no longer 0, 0, but it has. Now, the same applies to these columns, because you can choose to move one by one, but they are 4 in the same direction. I will just highlight them at once. And please note, you can do, when I go back to the view, you can move these in the 3D view. But for example, when you select this column and move it, you'll find, or you will be able to move them, but you'll find you have very many now points to snap to, because this is a 3D. That is why I'm doing the editing from the plan, where I have the X and Y fixed. So all I have to do is select these 4 columns. I want to move them inside by 0.05. So I'll come to the move, make sure I have the move toggled on. The translation vector, when you click at this location, it still captures the 0, 0, but I want them to move inside. So you can see the Y is now positive. So all I'm going to do is to keep these as 0, 0, comma, I will have the 0.05, the Y translation vector, then I'll keep this one constant. When I click execute, watch these ones, they are going to move. So I'll click execute and they'll move inside. So this is how you reposition them. Note when you do this repositioning from the 3D, you might move the column and you don't move the pin support. So you have to highlight everything, including the pin, before you move. But when I do it in plan, it is easier. I can move them very fast. So the other columns, we would orient them, but I'm going to just keep things brief. We can't fully exploit the power of robot in just a 2-hour session. So I'm going to move to, but these you would still move them. These you would move them and align them very well. So to position beams, you have to note where you are. We are at the first floor. So we are literally at the Z, which is 3.0, we are up. So if you draw them at the base, they will reflect at your base. So I will just open so these are the beams we have. They are 200 by 450. I'm going to sketch them. You can see how they move. These are cantilevers. So let us sketch. Now, for beams, as we said, you can pick them from here, you can pick them from geometry. But to go to geometry and you launch a beam, you can easily launch it from here. So I will launch beams. I'll launch beams. What we did for the columns, it's still the same. You will choose the reinforced concrete beam. We don't have, okay, it's there, but it's still the same process. You will have to come to these ellipses so that you can choose the beam you want. The 200 by, you choose the concrete. I'll go with C20. All these can be adjusted as you model. So this will be 200 and this will be 450. Why I'm not going to do it, because the beam is already here, 200 by 450. But you would just put your 200 and your, every time you input something, if you double click, the calculator will pop up. If you need to calculate and do anything, you just double click at wherever you input something, the calculator will pop up. You change its label and you add it, it will pop up here. So I'm going to just select the reinforced concrete beam. This is C25. So now it has a beginning, it has an end. Because you're modeling in a software that has the 3D part, just because we are in the XY, it might not be, but it's right there the moment you go to the view. So all you have to do is to choose the start, the beginning, and end. Remember, this is a horizontal beam, so it will draw it in the horizontal direction. So all I have to do now, don't just snap, because remember, the circle is the node. The triangle is the midpoint, the rhombus is the grid. So I will just snap to the grid and snap to this one. So a beam has been input. I will snap to this, snap to this. Because the beams are the same size, I will not change, but it does not mean the project will have the same beams. You have to generate all the different beams that you have here. So I'll just wait for the rhombus, then wait for the rhombus, then I'll sketch. Wait for the rhombus, sketch. Wait for the rhombus, sketch. If you just sketch, because robot is a finite element software, it in simple terms, finite element, if at all it's a slab, all it does is to divide that slab into very finite elements that are known at a certain x or a certain distance. Because basically, if you have an unknown function at infinite points, just imagine you have your x and y, and you have a curve, a function that is unknown at different values of x. Now, what the finite element analysis does is to change that function into into a function that is known at finite elements. So basically it will divide, for example, if it is a slab, it will divide it into small elements that are known at a certain distance x. And those are the elements it will analyze one by one and then combine them again to give you results for the entire slab. So that would be an explanation of finite elements. So I will just wait for the rhombus, wait for the rhombus. You just navigate over a point, wait for the rhombus, and snap. So if we go back to the view and we go to the 3D, this is basically what we are doing. These are the beams I'm sketching. So I'll go back to the plan. So let me try to sketch very fast. So I'm just waiting for the rhombus. You just navigate over a point. Because I know where the rhombus is, that is the grid intersection. So you can zoom in and get the point. Remember, as you also get near. So worry not if you, because we are modeling at a faster pace, you might have some few warnings that can be solved. So yeah, that shouldn't worry. So I'm trying to, because if at all we don't have beams complete, then the floors will also not be complete. So yeah, these are the beams now that we have. Just opening the 3D. So these are the beams. But as you can see, they are attached, their flange is attached above. But because they are in the same story, all I have to do, I can select them from here. So if I have all the beams selected, I want their flange to be attached here. I don't want them to protrude above, because this is where the slab will literally be attached. This will be like upstand beams, which only appear at floors or where you specifically need them. So to change this, you remember where we changed the angle from? When you come here and come to the offsets, there is lower flange and upper flange. For example, when you choose lower flange, you can see they have moved up. They have attached it using the lower flange. So when you check, as you can see now, I have a notification of internet. So in case you're unable to hear me, you let me know. But all I have done is to move them so that they flash with where our story stops, the 3.0. So this is what we have. I can go back to the view and go to the XY. So this is now what we have. So to move from this step, we need to apply to do the slabs. It's the same, the moment you use robot over and over again, the flows, how it flows, because everything is done from geometry and everything is toggled here. So flows, those are the different slabs. So when I launch the flows, as we did earlier for beams and columns, make sure the thickness, there is shell, you can model them in different ways. The same applies when you come to the flows. So this is where you get to specify exactly what you need. So we are going to have a combination of a solid slab and a ribbed slab, just for demonstration. So I'm going to have this as, I'll go with 175. It's constant thickness. I will change its label to 175 millimeter thick solid slab. So now what is critical is to uncheck the parameters for foundations or foundation elasticity, because if you don't uncheck, a robot is going to capture this as, because this is what we use to model foundations that are in contact with soil, or raft foundations, slabs that are in contact. You have to check this. So if you don't uncheck it, it will assume this to be a slab that is in contact and is modeled differently. So I'll just click add, and you can see it has been added. So I'll close this. I will still create one that is orthogonal. If you've encountered ribbed slabs, this is where you would model them from. So I'll just call it a ribbed slab. And all you have to do is define the H, the topping, you define the HA, the parameter A, and the thickness of your ribs as ribbed slabs are done. So I'm going to just confirm. Oh. So there is a ribbed slab that is already defined, but all you have to do is a ribbed slab. So you choose your H, maybe I'll go with 150. Depending on how you're going to have this, you might have it as empty space, you might have it with max span. So this might be influenced by that. You have the HA, the depth. I can go with 450. Parameter A, their thickness, so of the ribs, you can take one. Now this will depend on what you have and the different, so I'll still uncheck this, the different entities that you want to adjust. So this is where you can see this is one-sided, ribs in one direction. You can have unidirection, you can have on either sides. So all these, anything you think about, you can be able to model it here. So I'll just leave them as one-sided. And then you just add, they will be added and close. So all you have to do is select, for example, I will start with the 150 millimeter thick. Make sure this is shell. Now, you can model it using a contour, meaning you have to specify all the points. You can use the rectangle, which is faster. You only specify. So I'll wait for the, remember what we said? It is critical, so I can do it from the plan. So I'll wait for the rhombus, first point, second point, because I'm using rectangle. When I specify the third, the slab is modeled. Now, because you will later on do reinforcement, the direction by which you model the slabs matters. As you can see, I'm following the clockwise direction. The moment you orient this, I will just toggle this on. So this is the local axis. Every element here has changed the direction. For example, this is XY, and this is also tied to the reinforcement. The reinforcement will be specified depending on your X and Y plane. So you should follow one direction. If you choose clockwise, then this will be model. They will have the same local axis. The moment you change and model it anti-clockwise, you have oriented it, and you have as well, you have effect on the reinforcement, because you might put reinforcement that is meant to be in the X plane and you put it in the Y plane because you interchanged the slab. So we have a staircase here. I will leave that open. So all you have to do is zoom in, get the rhombus, and model. As you know, a slab is supported on different directions. So, oh, that was a node. I think that is where we shall have a small error, but we shall adjust that. So I'll model these ones. What is critical as you model? Note the signs that appear. The circle, the rhombus, the triangle are critical. And slabs follow the same orientation, so that when you have reinforcement in the X, you don't change and put it in the Y. So you see me slightly moving away just to have, so I'll close this. We shall go back to the 3D and we shall see what we have modeled. So there's a slab here, but we have used only solid slabs. I'm going to turn off these axes. I'm going to just delete this and have it as a ribbed slab, just for demonstration. So I'm going to change this to 150 thick ribbed slab. So, oh, this is a contour. So for contour, you have to click on all the points and then you close it from where you started so that it captures it. So using the contour. The rectangle, you only need 3 points. So this is basically what we have done. Yes, as I said, we can't exploit a robot in just, if you say I'm going to, because I'll leave a few minutes to, so I'm going to apply loads, then copy these to all other flows that we want, and probably we see how to, so I'm going to go back to the XY so that I'm in the, or you can use the plan. They are both. So to apply loads, you have to first define the load types. So for example, dead, always we begin with self-weight. Robot automatically calculates self-weight of the all you have put. So dead self-weight, you add it. The moment you add it, all the structures, all the entities you have, its self-weight will be captured. So we can have finishes. Finishes is also a dead load. So we can have finishes, we add it. This one we shall specify it. Then we shall have different partitions. You can have partitions on beams, partitions that are directly, they are all dead loads. So partitions on beams, we can have partitions that are directly on slabs. For example, where you probably have bathrooms, you might have slabs that are directly, partitions that are directly onto slabs. So we can have live loads. If we assume this to be a residential building, we have a specific residential live load. So I've turned the nature into a live load, residential live load. As per the code, you have a specified residential live load. We have the wet areas, then the saturation. Wet areas, those are the different washrooms, those ones, those are the wet areas. Codes give them different live loads. The same where you have stairs, where you have floors that have balconies. So the codes give them different saturation areas. So the moment you're done, you have now specified your loads. For example, when you come here, you can see there that now after specifying the loads, you move to the load definition. Now in the definition, this is where we get to apply the loads. You can pick it from here, or the moment you come here, you can see the load types we've been working on. You can get them from here, and these are the load definition. So now this is how we get to apply the loads onto this specific flow. Depending on the plan you have, you will know where the wet areas are. So I'll just assume these to be the wet areas and other flows to, if we had cantilevers here, though we didn't protrude them, we would have cantilevers here. So that it takes the saturation loads, but we have an axis for stair on this side. So we shall apply saturation loads here. Now for example, soft weight is covered. So we don't, when you got finishes, depending on the codes you are using, some engineers use a 1.0, some use a 1.8. So depending. So this will have finishes is depending on the flow you have, tiles, colors, so that weight. And it's a surface load. The 1.8, there are various ways you can apply the loads depending on what you have. For example, we shall use a uniform planar load so that it is applied entirely onto. So the uniform planar load, the blue shows how it is going to be applied. X, Y, Z. Now in the Z, I'll go with 1.8 negative so that it points down in the Z, the global. So this is the global, we are in the XY, I'll just go in the 3D, and this is the Z I'm talking about. So I'm giving it negative so that it points in the negative Z of our global axis. I'll go back to XY. So all you do is add, and I will just click on this. Then I'm going to, let me turn on the 3D so that these are the loads I'm applying. But yes, I can do it from here. So all you do is, because it's a surface load, you just need to click on that slab that you want. So I'll go back to the XY. So you just have to apply it on the flows on the specific. I'll just, yeah, it's right there. So I'll close this. I will then go back to finishes and toggle it. So here you can toggle off the load symbol on and off, and you can as well put the value. So you move, for example, when you're done with the finishes, we can apply the partitions on the beams, where you will have walls on the beams, depending on the usability. For example, here we shall not have, here we shall not have because this is an access, here we shall not have because this is an open area. So at this location of the beam, you will have a wall, and that is the load that we are going to put. So all you have to do is first change it so that you go to partitions on beams. If you assume a 0.2, that is the thickness of the wall that it is carrying, and we assume it to have a density of 22. Remember, our beams are 0.45, so they will reduce that height, which is 3, they will reduce it by the 0.45. So when you get a 0.2 times 22 times, you have 0.2 times 22 times the height, which is minus the beam depth, which is 0.45. So you have 11.22. Now that 11.22 is along the beam. Now, remember we used surface, so now we can use a member load, okay? So we can be able to apply a load on a specific member. So now all I have to do is, it is going to be still in the negative global Z, 11.22. I will add it. And all I have to do, as you can see, the cursor is already, I can do this in 3D. So all I have to do is click on the beam that has that specific wall, and the load will be applied. This is how load application and defining becomes very easy with various software. So all you have to do is specify the member, which is the beam that has that specific wall, and the load will be applied. I'm going to cover something small, then I will. So I'll go back to the XY. Now, after you've done applying the loads, you need to, and this is done, you need to verify. You remember we had that were not activated, but now they're activated because we've modeled a few things. So I'll save this just in case something happens. I'll just, yeah, the moment your model keep saving, in case of anything, you have a backup to start from. So you can do small verification before you eventually copy to other flows. So, and this is the meshing. You can pick it from analysis meshing, or you can, you remember the way we popped up the edit tools. So there are other tools for meshing. So I can put them here. So all those that you find here are all here. So for example, the meshing option, there are no panels selected. Yes, it will. Now meshing, I'll take, for example, 0.2. The more you make it fine, the more data you have, the more accurate it is. The more you make the mesh so big, depending on the structure you have and the plane that you're working on, so you have to choose a mesh size. So this is 0.2 literate. It's going to create meshes. You remember at finite distances. So it will have a small element that is 0.2 by 0.2 that it will analyze, and so I'll just keep that as 0.2. So this is the meshing option. So you can delete, you can freeze, and so this is the meshing option that we got from this side. You can as well pick it from here. So I can do meshing generation. So what robot is going to do is generate a mesh. And this mesh will notify you where you have inconsistencies. So where you have inconsistencies, it will notify you. You won't have, I will just go back to software it. You will not have a clean mesh. The moment you click on the different, you will not have a clean mesh. It will not join very well. So this is the simple check you can do. For example, here we must have probably snapped to a point that is not matching very well. That is why it is not so clear compared, for example, to here to here. So this is the mesh, and now robot, if you're to analyze, it will analyze every element separately and then combine them to give you results for this. So I will freeze this mesh so that it does not change in case of anything. How you toggle it off, you just click here. So it will be there in the background, frozen. Now with this, we can, if I go back to the stories, so this is where you get to create as many stories as you want. So you model the first story, make sure it is okay. For example, I'll just run simple verification to confirm. The moment you have warnings, elements that have not intersected, robot will notify you. So when you're done with the story and everything is complete, you have applied the loads, you mesh it, check it has no errors. Now we can automatically generate other flows. So when you come and select this flow, you go to stories, you can copy flows. So it is going to, maybe I can have 5 flows. So I'll generate 4 flows. So I'm going to generate using the flow that was okay, I'm going to generate other flows. That is basically what it has done. So I will just check out the filters so that everything pops up. So this is the structure. It has been meshed, but you first work on one and confirm everything is okay. Then when you check it has no errors, then you auto-generate other flows. Now, all these other flows will come with the different loads you applied. So you don't need to work on this other flow. In the interest of time, although it is interesting, I'm just going to open a project just to show you something small. So I will just open a project. So this is how a complete structure would look like. If, for example, I was to just pull out one flow because it is very possible. So I can pull out one flows, maybe I'll pull out the beams for this flow. So I'll just pull them out here. So this was a beam for the staircase. It is on the other floor. We can uncheck it. I can just show you something small. Okay, I think I had not run the iteration for this. Okay. I had not run iteration for this. Yeah, we don't have results for this, but it's okay. So this is how a complete structure would look like. I will just exit this. So this is how a complete structure would look like. We can do very many things, wind simulation in robot and so on. So I'm going to just use the last few seconds to just take you through what we have organized, what we are organizing. So we have a program that is coming up. We shall have it learning. If you are in our community, you must have probably seen it. So we have designed a robot structural analysis training. It will kick off in this same month on 25th. So we shall be able to go into the depth of everything, all the principles from how you choose what elements to use, what design standards you're going to consider. Where are we picking those roads? For example, I told you of 1.0, 1.8. You will model a structure and have it perfect. We always have feedback sessions on Saturday. So we do training for 2 days in a week. Then Saturday is a feedback session where you get to share your challenges and we get to analyze and solve them as a team. So we have a well streamlined course from modeling to, for example, road combinations. Where do they come from? We might be having fresh graduates. What is these different codes that people keep talking about and referring to? So you'll be able to get where the flows, the flow loads come from, the partitions, the different live loads, the wind, pressure, how we simulate it, and how all those different loads, the dead loads, the live loads, the wind loads, how they combine in order to have a combination that you're going to tell the software to analyze. Those 1.35 may be time bound, and the 1.5, we shall all understand how and where they come from and where they are applied, how and how the results look like. So this is what you will cover. In that, again, on every Saturday, we have a feedback session. So in that week, what we would have covered, where you have challenges, this is where we get to discuss them on a Saturday. So you have a Monday. For example, here we shall look at the analysis techniques, results, interpretation. Then on a Wednesday and a Friday as the feedback session. So everything from modeling to analysis to how you visualize the different elements. I've rushed through, for example, beams, columns. We shall go into the detail, how a column is positioned, how you decide its orientation, depending on the moment it is carrying in the different axes, the X and Y, because that is what governs the positioning of the columns. We shall go into the depth. You remember when I was modeling a slab, I told you to uncheck that parameter that is tied to foundations. We shall go into the depth, how robot models, for example, footing that is in contact with soil, because it has a lot of parameters that come into place. The size, the soil profile that is down, its bearing capacity, all that are captured, and it models your foundation as a spring. So that is the portion I unchecked because it would capture the floor slab with that spring analysis. So we shall do the different mats. We look at how the different foundations, the mat, we shall cover all these. So we have a detailed program. As I said, we can't cover the entire robot in 2 hours. So now whatever you output, because Robot and Revit have that collaboration, I remember one of the engineers mentioned it. If you've been in different design firms, you have a person that does the drafting, the detailing in different design firms. But now with Revit and Robot, you can model in Robot take it to Revit and you do all the detailing. And as you know, Revit is a BIM software, it's a building information modeling software. That is where you get to collaborate with different engineering fields. The plumbers, the electrical engineers will be able to collaborate within your model, and you'll be able to detect where crashes are, where a pipe maybe of SU is intended to pass through a beam. You'll be able to see all that within Revit. And that is the collaboration part, that all parties, wherever they are in different countries, can work on the same model in real time and be able to streamline and detect wherever there are crashes. That is the BIM environment. So whatever we've modeled, we shall be able to export it and see it in Revit and bring out all the details, what you have imagined, what you have detailed, the reinforcement you've designed, you'll be able to visualize it. And that is where Revit comes in. We no longer draw lines to represent a rebar. If the rebar is T20, it will come as T20, not just a line drawn, for example, that we used to do in AutoCAD. You detail a slab, you just draw a line, point to it that this is T16. In Revit, everything comes, if it is a T16, it will come as a T16. So the course will roll out. It's at 75 US dollars. You'll be able to keep in our community, you'll be able to get all the extra information. So I will just check. I know Engineer Gatimo had. Engineer Gatimo, are you still there? I know he had.
Hello, engineer. I am back.
All right. All right. I'm done with a few things. You can give us some few remarks. I've not looked at the chat. I don't know if you tried to answer some few questions. Yeah.
Your presentation was really, really good. I think it was pretty clear, so we do not have a lot of questions in the chat box. I will thank you for sacrificing your time to share with us. So thank you so much, Abraham. And then I'd also like to thank and appreciate all engineers who sacrificed their time and energy to join us tonight. So today we are going to be launching a new product on or a new course on robot structural analysis. If you would like to get a feel of how to use robots, if you'd like to get to master a robot and use it in your workflows, or if you would like to include robots in your design and analysis, you can get to apply for our course and be able to learn with us. So I'll share the application link in the chat box in just a moment. Please allow me to share the application link in the chat box. And then once you apply, we are going to share with you the course outline that Engineer Abraham has just the course outline that Engineer Abraham has just given you a brief overview for you to review it. And then if you have any questions with regards to the course, you may be able to ask us and we'll reply to you. Also, if you'd like to book a meeting so that we can take you through the course, please feel free to reach out to us throughout our channels and we'll be able to we'll get back to you All right. And then if you are not in our channels, please get to inbox any of us through LinkedIn, and we will also guide you on how you can apply for the course and reach out to the other members of the team. So thank you once again for joining us, and see you in the next webinar. So thank you and have a great night.